So you've got two sets of data. How in the world do you know if they're actually connected? Well, you might reach for a correlation test like Pearson or Spearman. But here's the thing. Choosing the wrong one can send you down a completely wrong path. Today, we're going to break down which tool to use and why getting this right is so critical. All right, let's just dive right in with something truly bizarre. Look at these two lines. They move together in this weirdly perfect sync. One line is the number of movies Nicolas Cage was in each year. The other, the number of people who drowned by falling into a swimming pool. The statistical correlation is actually pretty strong. So what's the deal here? Does watching a Nick Cage movie make you want to go for a swim and then, fall in? Yeah, probably not. And this is the perfect way to introduce the single most important rule in all of data analysis. Correlation is not causation. Just because two things happen to move together, it doesn't mean one is causing the other. Finding these little connections, that's the easy part. The hard part is figuring out if they actually mean anything. To figure that out, we need the right tools. So let's start with the big one, the one most of us learn about first, Pearson's correlation coefficient. We call it Pearson's R, and it's basically a number between -1 and +1. It tells you how well your data points fit onto a perfect straight line. A +1 is a perfect positive relationship. As one thing goes up, the other goes up right along with it. A -1 is a perfect negative relationship, and a key word here, the one you absolutely have to remember, is linear. Pearson lives and breathes straight lines. And look, when the relationship is clean and straightforward, Pearson is fantastic. Take this, for example, the link between age and systolic blood pressure. You can almost just draw the straight line yourself, can't you? The data points are all clustered right around it. The relationship is strong and it's linear. In cases like this, Pearson is absolutely the right tool for the job. And that brings us to a really great way to think about this. Pearson's R is like a rigid ruler. It's perfect for measuring things that are straight. But what happens when the real world isn't quite so neat and tidy? What happens when the path has a few curves? Because, let's be honest, the real world is messy. Our data is almost never perfectly behaved, and sometimes just one single oddball data point can throw a massive wrench in the works. Take a look at this chart. The Pearson correlation comes back as -0.70. Now, that's a strong negative relationship. It's telling us that as age increases, blood pressure goes down. And you can see that red trend line, Pearson sees a pretty steep downward slope. But hold on, is that what's really happening here? I mean, just use your eyes. Look at the bulk of the data points. Does that red line really seem to capture the true pattern? Or is something else pulling it down? Let's zoom in on that one lonely point way out in the bottom right corner. Now watch what happens when we just get rid of that one point. Poof! The entire strong negative relationship just vanishes into thin air. The Pearson correlation plummets to basically 0, the trend line is flat, the entire story just flipped, all because of one single data point. And that, right there, is Pearson's kryptonite. It is incredibly sensitive to outliers. A single weird value, maybe even just a typo, can completely warp the result and lead you to the exact wrong conclusion. That rigid ruler we talked about, it just got bent completely out of shape. This is exactly where our second tool makes its grand entrance. And it has a totally different way of looking at the world. Say hello to Spearman's rank correlation coefficients. This one's called Spearman's row. And here's the cool part. It doesn't care about the actual values in your data. It only cares about their order, their rank. It's built to measure something called a monotonic relationship. And that's just a fancy way of asking a simple question. As one variable goes up, does the other one consistently go up or consistently go down? It doesn't have to be a straight line, it just has to be consistent. So how does it do this? Well, it's pretty brilliant in its simplicity. First, you take all the values for one of your variables and just rank them, from smallest to largest, first, second, third, and so on. Then you do the exact same thing for the other variable. Finally, you just run a Pearson correlation on those two sets of ranks. By switching from actual values to simple ranks, Spearman becomes way less bothered by outliers and can suddenly see all sorts of patterns that Pearson would just totally miss. So if Pearson is our rigid ruler, think of Spearman as a flexible measuring tape. It can actually follow the curves and contours in your data. As long as the path keeps moving in one general direction, always up or always down, Spearman can wrap right around it and give you an accurate measurement. Let's look at this. I mean, you don't have to be a statistician to see there's a super strong relationship here, right? As x gets bigger, y consistently gets bigger. But because that path curves like an S, it's not linear. So our rigid ruler, Pearson, struggles a bit. It gives it a score of 0.85. That's pretty strong, for sure. But it doesn't quite capture how perfect this relationship is.
But Spearman? Spearman's flexible tape measure sees this for exactly what it is, a perfect monotonic relationship. For every single increase in x, there's an increase in y. It doesn't care that it's not a straight line. The rank order is perfect. So Spearman nails it with a perfect score of 1.0.
Okay, so now we've got two very powerful tools in our toolkit. We have the rigid ruler, Pearson, and the flexible tape measure, Spearman. This brings us right back to the big question. When do you use which?
Think of this as your quick and dirty cheat sheet. If you're looking for a straight line relationship and you know your data is pretty clean, with no crazy outliers, Pearson's rigid ruler is your guy. But if you think the relationship might have a curve to it, or if your data has outliers that you can't explain, Spearman's flexible tape measure is almost always the safer and often the more insightful choice.
So choosing the right tool is absolutely crucial if you want to find real, meaningful connections in your data. But no matter which one you choose, there is one final giant warning sign we need to come back to.
Hey, remember this thing? Finding a strong correlation, whether you use the rigid ruler of Pearson or the flexible tape of Spearman, is only the beginning of the story. It tells you that two things seem to be moving together. It's a clue. It's a hint that something interesting might be going on.
But a correlation test will never, ever tell you why. Answering why takes more than a formula. It takes expertise, it takes critical thinking, and it takes digging deeper. And that's the part that no statistical test can ever do for you. That's the real job of an analyst. And that is the most important question of all.